Hello and welcome to this presentation. I am Wouter and together with Michael we made a presentation about how the Internet of Things can help solve the challenges of the overgrowing cities. The number of residents is growing by nearly 60 million every year. In addition, it is expected that more than 60% of the world's population will be living in cities by 2050. With all these people living in the cities, we will face new challenges, like how to manage the food supply, how to sustain the environment, and how to control the trash and traffic, for example. In order to solve these challenges, we need to make the cities smarter. The Internet of Things can help a lot with these challenges. In this presentation, we will talk about smart cities, how they are now and how they can be in the future. We will propose a solution for the challenges that will be faced with smarter cities and discuss several protocols for this purpose. We will end this presentation with a quick summary and a conclusion. Let's start with a short video about how the Internet of Things might have an effect on you as a student.
Imagine everything was linked. Let's say a professor at the university is not feeling well and calls in sick. An automatic system at the school could send an alert to all the students that the class was cancelled. Furthermore, this information is passed on to a system that adapts my agenda. It calculates the new time to my next class 2 hours later, taking into account public transport timetables. It could also reset my alarm clock to wake me up a bit later, and it could adjust the central heating system and the coffee machine.
Imagine we had an Internet of Things. Wouldn't that be awesome?
Smart cities is not some futuristic term. It's happening now. Eindhoven is one of the examples. We take the waste management of Eindhoven. It's unique in its sort. All over the cities we have these waste containers. You can dispose your waste in there with your city card. The amount of trash you dispose is then registered into the system with your name, and the container itself checks if it's almost full based on the total weight and the amount of trash disposed. When it's full, it will send a signal to the system that manages the waste. 2 times a day, a waste truck drives off. Before it leaves, the system will check all the containers that are registered full, and it will map the fastest route for emptying all these waste containers. Because of this system, Eindhoven only needs half of its trucks and people they needed before to dispose the waste. With all the data they gathered about who deposits which amount of trash where, they can also make good estimations about where they can add more waste containers or where they can save on them. Next to Eindhoven, we also have Amsterdam, the biggest city in the Netherlands, which is making improvements in its lighting system to cut the energy cost. It's estimated that 90% of the consumed electricity goes towards light, and most of the street lighting still dates back to the 60s. They want to make the technology better and smarter, so they developed a system to track people's movements so the light only turns on when the people actually walk under the lamps. Aside from that, they made a smart system that adjusts the light's capacity based on certain factors. For example, when there's more traffic than usual, or when accidents are more bound to happen at certain spots. And if nothing is wrong, the lights can go off. It's estimated that they can save up to 115 billion a year when implemented in all the cities. A high density of the population in cities requires new approaches on how to handle the growing energy consumption and to reduce the waste produced. Citizens should be able to receive information from the authorities like transportation, healthcare, and education in real time. On the other hand, cities are interested in information about populations, such as the number of inhabitants and their distribution in the city, which constantly updates information rather than the updates that occur once in several years. This goal can be achieved with an implementation of the smart city concept, architecture that allows building the infrastructure required for such intensive sharing, collection and uses of information can be presented as in these 4 layers. The first layer contains all the end devices. These are sensors and network devices which are connected with a mesh network. The second layer is about data capturing, processing, storage and analytics. These points are distributed across the city. This reproduces the architectural complexity and ensures the easily expandability and extension. And which is most important is that it increases the responsiveness to real-time and context-critical data, which when processed enables information intelligence. The third layer is about central data collection, including computing, storage and analytics combined with integrated and open standard APIs. These allow for building on open data readiness. The fourth layer is for innovative application and services which can be built by residents and the city. The obstacle of monetization is a serious issue for city managers. When a project is launched, it is not clear how much is saved or made by these big investments. However, the number of projects that have been being implemented in pioneering cities like Barcelona, Amsterdam, or New York allows us to estimate such costs and evaluate profits, or better to say, savings from these new technologies. The example of lighting solutions can be considered as one where economic benefits are clear and well studied. Every city has its own unique architecture that requires a tailored solution, but the scale of existing lighting projects can provide approximate cost and benefits for possible solutions. Philips estimates that a complete switch to LED technology alone can generate savings of approximately 130 billion. Furthermore, an independent global trial of LED technology in 12 of the world's largest cities found that replacing normal light sources with LEDs can generate energy savings up to 50 to 70%, with savings reaching 80% when LED lighting is coupled with smart city infrastructure and applications. In order for the Internet of Things to work in smart cities, we need protocols like IPv6. But BI Intelligence Company estimates that the number of devices connected to the Internet is going to increase up to 30 to 35 billion devices by 2019. This number exceeds the theoretical limit of IPv4. Therefore, the use of IPv6, which has 2 to the power 128, is necessary to connect all the sensors, smart devices, and cars to the Internet. 6LoWPAN, which is an acronym of IPv6 or Low Power Wireless Personal Area Networks, is the protocol that operates only in a 2.4 GHz frequency range with a 250 kilobytes transfer rate. DTLS, Datagram Transport Layer. The DTLS protocol provides a communication privacy for datagram protocols such as UDP. The protocol allows client-server applications to communicate in a way that is designed to prevent eavesdropping, tampering, or message forgery. The DTLS protocol is based on the Transport Layer Security (TLS) protocol and provides equivalent security guarantees. LoRaWAN Network Initiative is across the world and in Amsterdam and in Eindhoven. According to the network world, trending in the IoT space is Wi-Fi and Bluetooth. However, experiments conducted using the LoRaWAN technology, if successful, may prove to be a good contender in the Internet of Things deployments. The range can vary up to 2 to 25 kilometers with a 10 on average, which is a lot higher than Wi-Fi and Bluetooth. LoRaWAN is designed to provide low-power, wide-area network with features specifically needed to support the low-cost communication of the Internet of Things. These features include machine-to-machine, secure bidirectional communication, and industrial applications. The main advantages of the protocol that can be used for building crowdsourced networks without a significant investment from larger companies. A number of parties in Eindhoven want to build such a network here. The first step for Eindhoven in Internet of Things have been put on placement of 2 antennas. One is in the clock building and the other one is in the social lab building at the Don Bosco Street. These antennas have a range from 5 to 7 kilometers. All kinds of sensors and activators may be associated with it. As said by one of the organizers, we built the smart city bottom up. The collected data will be made available through a publicly accessible gateway. Information exchange is planned through meetups and hackathons. When the net will grow and more sensors, computers, and devices will be connected with it, more developers will join the initiative and create applications that can ease the life of citizens and bring new opportunities. In short, we discussed the Internet of Things in smart cities, how this is already implemented in Eindhoven with, for example, the waste management, and in Amsterdam with the light infrastructure. We propose a solution of using the Internet of Things together with development of smart applications to solve these problems. We have discussed several protocols that can be used for this, like the IPv6, the LoRaWAN, and DTLS. Conclusion. To conclude, in order to solve the problem of overpopulating cities, we can use the Internet of Things to manage the different infrastructures like the traffic and waste, and we can adjust the lighting based on different parameters. Thank you for listening to this presentation.